Anusha, are you able to hear me?
Yes. Am I audible?
Yeah, you are audible. Please go on.
Yeah. A very good morning and a warm welcome to all the participants and respected speaker of the day. Myself, Anusha, the student coordinator in charge for CSPCS. On the primary note, I would like to thank Dr. MVV Prasad sir, in charge of COE CSPCS, John Moses sir, faculty coordinator CSPCS, and the respected HOD of ECE department B. Srinivasa sir. Also, I would like to extend my thanks to our respected principal, Dr. Suresh Akella sir, administrative and non-administrative staff, and our college management for giving us this wonderful opportunity to conduct such webinars during this pandemic period. The Center for Signal Processing and Communication Systems under ECE Department of Sreyas Institute of Engineering and Technology welcomes you to the webinar on Image Analysis and Pattern Recognition by Dr. X. Ascar Davix, Associate Professor, Department of ECE, RVR and JC College of Engineering. Sir, over to you.
So thank you. A warm good morning to you all. Before starting this session, I would like to thank Dr. John Moses, Dr. Prasad, and the HOD of ECE, then the management and the organizers. I'd like to thank you all. So the research scenario, the pattern recognition is a very growing technology. Also, it is supported for artificial intelligence. So finding the objects and taking some decision, understanding the objects, understanding the motion. So these all related to the pattern recognition. So the participant, sometimes some listener may be new to the field of image processing. So I would like to give some introduction on image processing. So image processing, it is there are major two tasks. One is improvement of pictorial information, and another one processing of image data. These two are different. One is the improvement of pictorial information, and another one processing is on data. So the first case, the processing is done on the image. Consider one image, the processing is done on that image. That is the first case. And in the second case, the processing is not directly done on the image. Processing is done on the data which are extracted from the image. So these two are different. So see this image. This is one example grayscale image. So when we see the image, we can see all the objects, a building, a ladder, and some trucks. So that's all. So what computer sees? The computer which understand the binary values only. Okay. So here, this is the matrix. So this is the format which the machine can learn, machine can read. So there are 9 rows and 9 columns. There are 9 rows and 9 columns. So the square is represented as pixels. This is called pixel, and each pixel having some intensity value. So this matrix is not for the entire image. So it is for a small portion of the image. Consider a small portion of this image and it is expanded. So small portion consists of 9 number of rows and 9 number of columns. So each pixel carrying some intensity value. So this intensity varies from 0 to 255. It is a grayscale. And there are 3 levels of processing. One is low level process, mid level process, and a high level process. In case of low level processing, the input to the system is the image and output is also image. Example, noise removal, image sharpening, some enhancement, that's all. So we are providing the example, we are providing a image with noise to the system, and by applying some filtering concepts, so the output will be a image without noise. So that is the low level process. And in case of mid level process, the input is image and the output is attributes. Attributes in the sense these are some features extracted from some objects, features, patterns, or objects. These are the attributes. So, example, object recognition, segmentation. So, while segmentation, small note about segmentation. What is meant by segmentation? If you want to partition a A4 size paper, normally, if you want to partition this paper, what we will do? Partitioning the paper by 4 means we will fold the paper by 4 and we will tear it. Now the paper is partitioned into 4. But considering image, consider a full image, the segmentation means the image consists of background as well as objects. So the objects available in the background or available on the background are segmented or separated or partitioned. So this is the exact meaning of segmentation. So these segmented objects that has some attributes, some features, we can extract some features from the object. So that is called these attributes. So input is a image, but we are getting some attributes, features are the output. And for high level processing, we are providing input these features. The attributes are given to input of this process and some understanding. Understanding in the sense, example, the security camera, while it detect the movement of people or any animal or some other things, it will detect. And some unwanted person is there, it will detect. It will detect the persons, but they don't know this person is unwanted person or not. So that is understanding. We have to give some understanding based on some criteria. So that is our high level processing. And what are the key points in the digital image processing, the overall field? Image acquisition, enhancement, restoration, morphological, segmentation, object recognition, representation. So the first step is image acquisition. So acquisition in the sense capturing the image. So this is the principle of capturing the image is exactly equal to how our human eye can see the objects, see the image. When you see the outdoor scene, how we can see the objects. So to see the objects, there is a necessity of illumination. A source is necessary. So example, sunlight. So when you see the object, light from the source is incident on the object and the reflected light is absorbed by our lens in our eyes. So the reflected light from the object is observed by our lens in our eyes, then the image is created. So till hitting the object, the light, the color of the light may be white. And after reflection, what happens? It will reflect the intensity of the particular object. So that is the concept. You can see here, this is the illumination, maybe sunlight, and it is one object. When sunlight falls on the object, it gets reflected. While reflecting, it gets the intensity of that particular area. So the different lights are reflected. Each reflected light carrying different intensity. It is false absorbed by the sensor and it is converted into electric pulses and it is stored in the array. So see here, there are some squares. So each electric pulse or each value is assigned to a pixel. It has some intensity value. Each pixel carries different intensity. Based on the intensity, the image object that is observed or that is seen in the screen. That is the concept behind the image acquisition. So based on this concept, the cameras are designed. Then image enhancement. We know enhancement means improving the quality. How we can improve the quality? So this is the low contrast image and this one a high contrast image. So histogram processing is there. By understanding the histogram, histogram equalization, histogram matching, some concept there. So we can improve the contrast of the image, improving the quality. Then restoration. So in your computer, if you delete one file, it is available in the recycle bin. So in the recycle bin, when you restore the file, again it is located in the original location. So likewise, this is our input image. This is our input image. So it is a corrupted one because it lost many intensities. So its original image may be like this. So this, consider this is the original image, and this image, it lost some intensity. Many intensity values are missing. So by predicting the neighboring pixel values, we can restore the original data. That is the reason of the restoration. Then morphological, it is a structure-based processing. This is also input image, output is also image. It provides a skeleton-based objects. The objects are given as a skeleton-based object. Closing, opening operation, dilution, erosion operation. By using that, we can fill the gaps and we can remove the unwanted elements. That's all. Then we can come to the segmentation. So till that, it is a low-level processing. Input is also image, output is also image. While coming to the segmentation, consider these two objects. This is object 1 and this one object 2. So if you want to segment these two objects, so the background is purely white. When you see the histogram is the number of pixels having the same intensity. So number of pixels having the same intensity is grouped here. So this may be the first object. Then this peak, this is the second object. In between that, there is a gap. It shows the background. So the object represents a peak histograms. So clearly we can see there are two objects. So these two objects can be segmented. Then object recognition, how we can recognize objects. So that we will discuss. And representation. After recognition, we can represent the objects. We can give some particular structure, and this is an example of shape number. How image representation is done. Object representation is done by shape number. Then image compression, we know that by compressing the image, we can reduce the storage, as well as when you want to transmit the images, this can be helpful. And color image processing. We can process the image from grayscale as well as color image. Color components consist of three components that we will discuss. This is the matrix format of an image. This is the origin, and m-1 number of rows and n-1 number of column. So example, m is equal to 10 means there are 9 number of rows and n is also 10, 9 number of columns. So we are going to, the computer will process on these pixels, this matrix. This is a matrix. Each matrix consists of different intensity values. All the operation will be done on these pixel values. So there are different image types. Intensity image, consider the entire image. We are taking a small portion of the image. So this small portion is expanded here. The expanded view is here. Again, we are considering a small portion. The size of this image is 4 cross 4, which means 4 number of rows and 4 number of columns. The total number of pixel in this region is 16, and the pixel values are given. These are the intensity value. These values ranges from 0 to 255, but it does not has any color component. Only the brightness value. It does not has any color component. That is called grayscale image or intensity image. While considering the RGB image, so here this is the color image. We are taking a small portion of the image. Here this is the expanded view. In that expanded view, again we are taking another small portion. The size of this image is 16 pixels, which means 4 column, 4 cross 4 matrix. So this is expanded, this 16, 4 cross 4 image, this is. So it has 3 components. The previously, so the small portion, it has single component, single plane. So this is the grayscale value or grayscale image. And here, the same image has three components: red component, green component, and blue component. So red component has some intensity value ranges from 0 to 255, and the green component having some intensity ranging from 0 to 255. Likewise, blue component also the same. So by combining these three, so these are called primary color components. So by combining these three primary color components, the secondary color will be generated. So likewise, by the combination of different colors, we can see a different colors in the objects. So from this, we cannot see this to this. So bottom to top approach. That means from this pixel, it is formed again. We are getting this image. This is the portion. Likewise, the entire image is formed. Another one, binary image. We know binary 0 and 1. Here, 0 represent black, 1 represent white. So there are two set of intensity only. One is 0 and another one 1. So 0 means black and 1 means white. So here we are taking a small portion. This is the expanded view. Again, considering a small portion, 4 cross 4. First two rows are 0. So it is a black. And the row 3 and row 4 are 1. So it gives white. So this is the binary image. Index image. So from this image, we are taking a small portion and we are representing not the intensity value, and it is the index value. So there is a color table. From that color table, the index representing some color components. What is the value of red? What is the value of green? And what is the value of blue? So this combination will be assigned by this indexing. So if it is 4, then this pixel contains the RGB component, this value. And if it is 5, and this corresponding pixel carrying the RGB component value is this. So this is the index image. And the matrix form, this is the center pixel, and these are the neighboring pixels. We should learn about the neighborhoods. So there are different types of neighboring pixels. Consider this is the current pixel. If it is 4 neighbors means, so the vertical 2 pixels and the horizontal 2 pixels. So these 4 are the 4 neighborhoods. So if you want to make some process on this particular pixel, so if you are changing, initially the intensity of this pixel is 20. You are going to make some process. After the process, the intensity maybe varies. Definitely it will varies. Maybe from 22, it may get value 25. So how it gets? So this operation is based on the neighboring pixels. So if it is a 4 neighborhoods, this is the structure, and the diagonal neighbors. So these are the 2 diagonal neighbors, 4 diagonal neighbors. And likewise, 8 neighborhood means it consider the surrounding entire pixel. So the process will be carried out on the 8 neighboring pixels. So that we can decide. And spatial. So in image processing, the processing is done in 2 domains. One is spatial domain and another one frequency domain. Spatial domain, the processing is done on the pixel. We are taking the image, we are making some process on that image. And in case of frequency domain, we are using some transformation. We are converting our image into some other domain, frequency domain. After converting it into frequency domain, then we are extracting some features and we are making some process. That is the frequency domain. So spatial domain, what are the example of spatial domain? Single pixel operations, negative image, contrast. These are the pre-processing. Then applying the filters and some spatial transformation, and these are the scaling. So these are the spatial operations. Single pixel operation. So we are making some process on individual pixels. Here, the black is converted into white. This is the binary image. 0 converted into 1. So binary image. So operation is done on a single pixel. Then we discuss image analysis. What is the need of analysis of image? So while analyzing the image, so considering a image captured from a security camera and the automatic parking system, and some toll gates, automatic toll gate system, and wherever, even though if it is a video, and for processing, it is converted into, even though it is video, it is converted into image frames. So the processing is done on images. So by making some analysis, or we can extract some data. So we discussed low level processing. Low level processing, the input is image, output is also image. In case of mid level processing, the input is image, output is attributes, some features. So based on the extracted features, we are making some analysis. The image analysis is done on the data extracted from the image. So some field, image description, image understanding, pattern recognition, it is applicable in artificial intelligence and computer vision. So this is one image fingerprint. So the biometry, this is one pattern of fingerprint. So the system needs to understand the pattern. So when we see, it is complicated, but when we extract some features from this image, or from the thumb image, some features are extracted. Then we should match with the testing data set. So after matching, we can identify which person this. Likewise, face recognition. So these are the image classification and image understanding. So we can identify there is a door. We can identify, and some understanding means whether the door is open or closed. That is some understanding. So that is also possible while analyzing the image. So the steps involved in the image analysis, the pre-processing, this is the low level. Segmentation, we are segmenting some objects, and feature extraction. We are extracting some features from the segmented objects. So these features are given to the classifier for some classification. So some examples of computer vision applications. Optical character recognition. So we know the mail sorting, label reading, product billing, bank check processing, variety of applications. It define the characters and medical image. So variety of application in the field of medical image, tumor detection, size and shape, measurement of organs, chromosome analysis, and etc. And industrial robotics. Here the recognition part, recognition of object in a scene and motion control. Then cartography, so some map making photographs. Then forensic department for the remote guiding of missiles and military applications, many applications. So this is one image. This is example of optical character recognition. So from this image, it is converted into binary image. It is inverted image. Again, it is rotated. Then for each character, it is identified, and finally, it is concluded. It is 9. So optical character. So what we will done beginning this image analysis? First, we are doing segmentation. By assigning some threshold, we are segmenting the objects. So different segmenting process there, boundary based segmentation, then region based segmentation, template matching, and texture segmentation. And next we are going for feature description. Feature description, here spatial features, transformation features, edges, shape features, a variety of features. So that should be selected based on our application. The features are selected based on our application as well as the efficiency of the classifier. Then classification. So clustering, so many classifier, neural network, decision tree, statistical and similarity measure, some matching algorithm, different classification techniques there. After extracting the features, we use classifier to classify the objects. So segmentation. Already I told you the segmentation subdivide an image into some components. That means it will segment the objects. So from the background, the foreground objects are segmented. Here, this is the aerial view, satellite view of land. This area is a tree, maybe forest, and it is a cultivated land. So even if you see the color image, each part contains a different intensity. With color, different color in the sense different intensity. So it has green, and each has some intensity variation. So from this area, this is area 1. From this area, and this is area 2. So there should be some difference. So the intensity is varied. Intensity is varied for along this boundary, not the entire image. So along the boundary only the intensity varies. So based on this, image segmentation is done. So here we can see how it is identified. So this is region 1, region 2. So different regions are identified based on the variation of the intensity and variation of the intensity, and also consider the first region. So the pixels in this region, the intensity is almost the same. So based on the similarity, it is grouped, similarity of the pixel. So along the border, when it is varies, it comes under the next region. So this is image of a cell, how the cells are segmented from the image. Thresholding. Thresholding is important in the segmentation. I told you the grayscale value ranges from 0 to 255. So how the thresholding is applied? 0 and 1. If it is 0 means black, 1 means white. If example, we are taking the threshold value is 100 and the neighboring pixel, compare with the neighboring pixel, if the value is less than 100, it will give the value 0, and if it is greater than 100, it assign the value 1. So based on the threshold, the binary image can be varies. So here some threshold function is applied here. So this value, so the number of pixels having value less than this threshold, it is grouped into a single part, and that may be 0, and above the threshold value, that is considered as 1 or white. When we see this image, one example, a threshold value 128. So this is the original image. So if the threshold is 128, this image is converted into binary, which means it will check all the pixels intensity. If it is less than 128, it assigns 0, that becomes black. And when it greater than 128, it assigns 1, then it becomes white. So the next example, the threshold is reduced. What happens when the threshold is reduced? The number of darkness, the number of 0 is reduced, because here less than 128 is considered as 0, here less than 50 is considered as 0. So when you compare these two, here there are more black region, here there are more white regions when we change the thresholding. So after thresholding, we can identify some objects. So when the threshold is 128, we cannot guess more objects. But when you reduce the threshold, so based on the application, we have to assign the thresholding. And some textures. So what is a texture? Texture is also a pattern. It is the surface character of an image. So based on this texture, the region is separated. So from the separated region, again we can extract some data, and it can be used for the classification. So there are different segmentation methods. Region-based segmentation. Region-based, there are two types: region growing and region splitting. So consider a small pointer image, and based on the similarity of the intensity, the region is grouped. That is the region growing. And based on the intensity value, the region is splitted. That is the region splitting. So this is also a region-based segmentation. Here, the segmentation is done. So this area, it is green in color. The intensity, mostly entire this area, the intensity is same. So the similar intensities group is a region-based segmentation. So this region, the intensity is equal, almost equal. So this is considered as a single region. And again, this is sky, this is another one region, water, another one region. So this board, this is white region, this is also some region. So likewise, based on the similarity of the intensity, the objects are identified. Then we discuss the pattern recognition. Pattern recognition, in the sense, it is used in the automated system. It gives recognition intelligence to machine. So normally the machine does not have any intelligence. So we are educating the machine to act as intelligent, which means we are providing some data and we are providing some training. Based on the training, the machine will understand, or machine can decide what is it, what to do next. That can be decided by the machine. So that is also used in the artificial intelligence. The definition of pattern: pattern is an object. So pattern is an object. Consider uh, 5 balls on a table. When you take an image of this this scene, what happens? The balls are the objects. The remaining are the background. So when you consider the balls are pattern, we can get some information. So the object is also a pattern. So pattern is an object that can be given a particular name. And pattern class. Pattern class is nothing but set of patterns sharing common attributes. Example, on the table there are 10 balls, 5 red color balls, 5 green color balls. What happens? So when you take image, all the balls are patterns, but pattern class, in the sense, there is a two classes, red and green. So red balls comes under red class and the green balls comes under green class. So the pattern sharing common attributes is combined together and forming a cluster, that is the pattern class. And classifier. By applying a suitable classifier, we can make some understanding. This is the example of pattern. A small pattern is available, a circle and a dark. So this is one pattern, this is another pattern. So some shape objects. So this is the pattern. Also, the pattern varies with some parameters. Based on some parameter, the pattern varies. Here one face. So this is the normal, and the pattern vary with expression, lighting, and occlusions. Here some pattern variation based on expression. So while using the glass, what happens? Some pattern varies. You cannot get the pattern data from the eye. And here it is smiling. So for each image, it is different. So for each image, the features are somewhat different. You cannot get the same exact feature. So it varies. So it is used in the face recognition. Speech pattern. So from the speech signal, we can recognize the emotion, the person, what is the emotion of this person, and whether this person is telling true or not, lie detector, and many applications. From the speech signal also, we can extract some data. We will get some patterns. So this image, the forest area and the cultivated area, we can classify. So from this region, we will get some information. By using that information, we can conclude this is the forest. And this area, it is a cultivated land. So before that, we should know what is how the future value will be there for cultivated land. By studying that, we can estimate what is the land here. And here also the same. It is used in the coal mine detection. So the coal detection. So based on some feature from the satellite image, based on some feature, we can have a conclusion there is a possible of coal. So some applications, handwritten and recognition, biometric, thumb impression, fingerprint biometric, face recognition, speech recognition. So variety of applications. How the pattern recognition works? The process consists of two major operations. One is feature extraction and another one classification. After image segmentation, we will get different objects. So from this object, we are getting patterns. So for this, the process is called feature extraction. And these extracted features are classified and it is assigned to a particular class or category, forming some clusters. It will be done by classification. So here, all the extracted features are clusters. Here what happens, by using the classifier, we can categorize these features. So this is one outdoor scene. You can see mountain, big building, here buildings, some shops, one lamp, here also one lamp, many people are moving. So many objects available. How we can identify? It will detect are there people, whether any people are there, and is there any lamp? How it will detect? Is there any big building? Here it is represented palace, a big building. Likewise, a mountain and a tree is available. So a single image consists of many objects. How we can classify? So as human, we know all the things, but the machine does not know what is the thing. So we have to educate the machine to understand these objects. So that's why the pattern recognition gives recognition intelligence to machine. So how to recognize mountain, how to recognize tree, how to recognize people. So these are, we have to educate the machine to recognize. So by recognizing, the machine can understand, machine can have understanding. The image is taken, it is outdoor, this may be city. So it comes to a conclusion. What is it? What is it? So by using that objects, what is the conclusion? That the machine will do. So the pattern recognition, to understand that we are learning the machine, we are educating the machine. So there are three types. One is supervised learning, and another one unsupervised learning, then reinforcement learning. What is meant by supervised learning? There is a supervisor to educate the machine. A teacher provides category label. Example, you consider 10 balls on a table. There are six red color balls and four green color balls. What we are doing, we are taking the pattern of red component. We are extracting the feature of the red balls. And we are educating the system, educating the machine. If this pattern, this feature is available, then you can say it is a red color ball. And we are extracting feature from green color ball, and we are educating the machine. If the feature value is this value, then you can say it is a green color ball. So we are educating. We are assigning some label. Initial, we are assigning some label to the extracted features. So this is the supervised learning. And what is meant by unsupervised learning? In unsupervised learning, we are not educating or we are not giving any label. What we are doing, we are extracting the features and we train the machine to categorize the similarity of the features. Example, the machine is extracting the feature from the 10 objects, 10 balls it is extracting, and it will group the features, group the objects based on the similarity of the features. So the machine what will do, it will extract the feature of all the balls and it will group the objects based on the similarity. What happens? Definitely 6 balls having the features, similar features. So that 6 is grouped. Again, the 4 green balls, that is grouped in a single. So likewise, we are classifying the objects. After that only, we are deciding what is it. This is the unsupervised learning. Reinforcement learning. So it is used to make give a conclusion whether the decision taken is right or wrong. So supervised learning. In supervised learning, the teacher provides labeled training. Here, example, there are few shapes, a triangle, and also in that triangle, there are two colors. One is yellow and another one blue. And also, few triangles are small and other triangles are big in size. So we can have different features. What is the differences? Shape is different, color is different. There are two differences, shape and color. When you say take this, there are also two colors, yellow and blue, and shape is also different. Sorry, size is also different. But when you consider these two, shape is different. So there are three features we can take. One is color, and another one size, and another one shape. So we are giving to the classifier. We are extracting features from all the objects and we are giving to the classifier. So it will identify. If you consider the feature is color, then the classifier will understand the feature value of the yellow color and classify accordingly all the yellow objects. That means the feature extracted from this image are similar. Similar features are grouped here. Also, the other similar features are grouped. Definitely, it will be a blue object, it will be a yellow object. And unsupervised. In supervised, earlier we are training the classifier. So if this feature is there, then it is yellow color. And the feature is this value, if it is blue color, we are labeling. But here, there are group of components. All the objects are mixed together. So unlabeled training, there is no labeling. The machine don't know what is yellow, what is blue, what is triangle, what is circle. The machine don't know anything. The machine is having some objects, and the machine, we are extracting the features from all the objects. So based on some criteria, we can classify. So based on some criteria here, what does means while considering this, here the shape is considered. While considering the shape from that mixed group, mixed objects, we are considering shape feature. So it will identify the shape feature. The shape in the sense, if this is the triangle, how will you identify the shape? From the three corner, it will draw a line and there will be an intersecting point. And the distance between the intersecting point. Otherwise, we can have an angle. So different concept we can use to identify the triangle, identify the shape. Also, if it is a circle and the radius, so finding the center of the object and finding the radius, if all the radius are equal, then we can say it is a circle. So by using any of the concept, we can assign some shape features. So if you find the shape, then based on that feature, we are classifying. All the rectangle, the triangle shapes are classified into one, and the remaining, the circle shapes are classified. This is the shape-based classification. And here, this is size-based classification. We can find the area of triangle, find the area of circle. So by finding the area, so if it is this much area, then it is grouped a single, and the area is some other value, xy value, then the area of y is grouped here. So based on the size of the object, it is classified. Here, based on the color, we are extracting all the features of a color, the intensity values. And based on similarity of the color feature, it is classified. Then automatically blue components are classified. Again, yellow components are classified. So initially, we are not assigning this is triangle, this is yellow. We are not assigning. But what the system do, it classify the objects. After that, we can give some understanding. So features, the features may be different. If it is a object, consider this as we discussed. This is the shape feature, and this one, it is the size, and here it is color. Based on different feature, this can be classified. So based on our application, we can consider many features. So another one important thing, feature vectors. So here, X is the feature vector. X is the feature vector. This vector contains the feature of a particular object. Consider this triangle. So we are considering three features: shape, size, color. X1 is shape, X2 is size, and X3 is color. There are three features we are taking. So the feature vector X contains the values of the features, the three different features, X1, X2, X3. This is the feature vector. So this is the space, feature space. So this X is located on this feature vector space. So X1, X2, X3, this X is a point in the three-dimensional feature space. So it is located. So likewise, the feature vector, this feature point, this point of another object, that is also located. So for all the objects in the space, the points are located. When you locate the point, and based on some decision boundary, we can classify if the objects belongs to which category. So feature vector. So feature vector, the same features, but it is two-dimensional. Only two shapes are considered. Two features. Here it is shape and size. Shape is triangle and circle. Size is small and big. The X1 is shape. X1 is shape and X2 is size. So in X1, the shape. In 0, the entire vertical, the circle. Again, it is triangle. So this grouping, it is diamond. So based on the shape. And in y-axis, based on the size, the row wise, this group is same size, this group is same size. So based on which parameter, which means which feature we are considering, we are getting the grouping. On case study, how the classification will be done. A conveyor belt carrying fishes. Okay. There are two fishes considering sea bass and salmon. There are two different fishes. So conveyor belt carrying these fishes. and automatically the system have to recognize which fish is this. And first the system need to understand and recognize, then classify the fishes and keep it in a separate box. So how it will be done? The capturing image, isolating, taking some measurements. Measurement in the sense, what are the features we are taking? Here the features are, many features it can be possible: length, width, weight, number of fins and shape of fins, tail shape, and etc. What are the things possible we can take? And based on these features, it can be classified. So multiple features they can take. Here they are considering the lightness and width. Only two features they have considered. So the features, after after finding the features of all the, consider one fish, finding the feature, and that feature is considered in the feature vector, and it is forming a, locating a point on the feature space. So this is the feature space. It is one point is locating. So there are many fishes, many objects. All the objects values are located. Then what about the classification? So there are clusters. There is some clusters, and here also some clusters. There is some mixing. How to separate this? So these objects are, this is a salmon fish and this is a sea bass. So how to recognize this? How to classify? So for that, a simple Bayes theorem, it will give a decision boundary based on the difference. Based on the difference, it will form a decision boundary. After forming the decision boundary, the left side of the boundary gives one category, and the right side of the boundary provides another one category. And if it is linear, the features are located in a right way, and this is a linear boundary. Sometimes linear boundary provides a better result. In case of some mixed features near the boundary, if some features are mixed, then we go for non-linear boundary by assigning the probability density function of the Bayes theorem. Then we can get the non-linearity decision boundary. By assigning the non-linearity decision boundary, we can classify the categories of objects. So this is the example of features. So this is the example of good features. So if the similar features are combined together, and this is another one type of feature, the features similar to this type are connected together. So this is when we see this, we can see a very good clustering. So there should be some separation. This is a linear decision boundary. So if the features are aligned this, the result will be very accuracy. So left side of this boundary, this is one category, and the right side of this boundary, it is assigned another category. And if it is mixed, all the features are mixed, it is very difficult to take a decision. So these features are bad features. So it is very difficult to give a conclusion. So different classifiers. So what is the use of classifiers? After extracting the features, forming the decision boundary, and how these features are classified. This belongs to this which category? These objects belongs to which category? How do we categorize? That is done by classifier. Different classifiers there. A basic neural network classifier. It has input layer and output layer. If it is necessary, it has the hidden layers. So it gives some decision because it is very good because all the nodes are connected. The second line, this second layer is connected. The input of first layer, all the output of the first layer is connected to all. So the efficiency will be more. The k nearest classifier. So this is also see this example. here one point is there. So we have to identify this point belongs to which category. So inside the circle, K nearest, with a small nearest neighbors, we are taking a particular region, and this point contains which category, whether category 1 or category 2 or category 3. So nearer to this, number of ones are 4. There are 4 number of 1. 4 number means there are 4 objects, and there are 2 objects category 2, and there are 3 objects. So this point is related to this one. The system will understand this point is related to the category 1. So this is the K nearest classifier. K means clustering. So initially by assigning k number of clustering by finding the mean value of the neighborhood pixels. By finding the mean value of the neighborhood pixels, there are different clusters formed. If k is 3, 3 clusters formed. If the k value increases, based on that, finding the neighboring mean value, it will find 5 number of clusters. This example, there are 3 number of clusters finding the mean, and these are separated. Again, finally we'll separate each object. So it is connected to a single group. This is the another category. This is also a separate category. And this classifier, how the efficiency of the classifier, that can be analyzed or evaluated by a confusion matrix. Here we can find the true positive, true negative, false positive, false negatives. So here one example is there. Actually, the number of cat is 5. The number of cat is 8 totally. But how much it is predicted, the classifier? Among the 8 is identified 5 as cat. These 3 are identifying the animals. From the image, identifying the animal, cat, dog, and rabbit. Totally 8 cats. Among 8, 5 are identified as cat. They 3 identified as dog. So dog totally 6. Among the 6, only 3 are identified correctly. And the rabbit, 11 are identified correctly. So by using a confusion matrix, we can find many parameters to measure the performance of the classifier. So by improving the features, the extracting features, and when it forms a clear vector space, and then if you are getting a very good decision boundary, when the good features, then the efficiency will be more. So we should concentrate on what kind of feature we are extracting, and from the extracted feature. So if the number of feature is increasing, the efficiency automatically is high. So these are the things I would like to share with you. These are the references I have referred. Once again, I thank you for providing this opportunity. Thank you, Dr. John Moses. Thank you, Dr. Prasad and HOD and the Sreyas management. Once again, I thank you all. Thank you.
So the queries are open to all the participants. Any queries regarding today's presentation, you're free to ask. Any queries?
Sir, there is a question, sir. I am reading it out.
Yeah, I can see. Is there any way to select a particular algorithm for different application? Yes, sir, definitely. Based on but the same algorithm can be used for different purpose. But what is the thing is, while extracting the features and making some classification, it may not be accurate for all the scenarios. So there are some drawbacks uh, based on the occlusions, and the feature maybe varies. So based on a particular application, if we are finding the toolkit, a vehicle, and the distance between camera and the object is very close, then if you are using some algorithm, it may provide a better output. But while if the season is rainy and the object is not visible, then it is not worth. So you have to improve some other features. So you have to improve the features, but the same algorithm we can use. And another one, reinforcement learning. Reinforcement learning actually finding our decision. The machine is taking some decision, whether the decision is right or wrong. To evaluate the learning process, to evaluate the testing, it is used reinforcement learning evaluation.
Sir, looks like, sir, there is one more question.
Yes, ma'am. What is that now?
Um, the question is, sir, for haze removal techniques, which classifier is help? Which classifier is help?
For classifier, actually, we cannot say which classifier is best. Now, people are using support vector machine, and based on the feature you are extracting, you have to use a classifier. Mostly, the support vector machine is useful for a better classification. Also, the neural network, but the time complexity is more when you change the classifier.
I think we are so far done with the query session, sir. So thank you, everyone. I would give my special thanks to Dr. X. Ascar David, sir, for giving us your valuable time and for sharing knowledge with us. Thank you once again, sir. It was really a very great learning experience. Also, I would like to once again thank MVP Prasad, sir, in charge CEO SPCS, John Moses, sir, faculty coordinator CSPCS, our HOD of EC department Srinivasu, sir, Principal Suresh Akella, sir, administrative and non-administrative staff, and our college management for giving us this wonderful opportunity. I hope this seminar was extremely useful and informative. Thank you all for your wonderful participation. Hope the same continues. And before we could wind this up, I request all the participants to make sure that you drop down your mail IDs along with your full names in the chat box for feedback and certification. Thank you.